how are you tonight? So our event is beginning now. Feel free to grab a seat. Thank you so much for coming to our event and support Taraxa. And we hope you had a great time during San Francisco Blockchain Week. At the very beginning, please allow me to introduce a little bit about this project, Taraxa. And we will have our CEO and founder of Taraxa, Stephen Pu, to be our first speaker. So Taraxa is a fast, scalable, and device-friendly public ledger designed to help IoT ecosystems become more trusted, autonomous, and valuable. Taraxa is funded by Stanford alumni with a focus on facilitating IoT data sharing and trading. The project's tech highlights include rapidly finalized DAG, concurrency inspired by STM, fuzzy sharding, trustless light nodes, and adaptive protocol, which will be introduced during our founder's speech. Taraxa introduces significant new innovations, such as concurrent smart contracts based on the principles of STM, practical trustless light nodes for IoT devices, and encrypted data markets. It is well-funded and has a slew of partnerships negotiated, ready to deploy applications on our protocol once the mainnet launches. So tonight, our first speaker is Stephen Pu, CEO and founder of Taraxa. Stephen is an IoT and healthcare entrepreneur and also a strategy consultant. He has a BS and an MS in EE from Stanford University. So let's welcome Stephen Pu.
Hi everyone.
Can you guys hear me?
Yeah.
All right.
Yeah.
Usually when I'm speaking, people tell me to shut up because I'm too loud. So I figured this time. All right. It's really great to be here, and thank you everyone for coming all the way over here to attend our event. So today I'll tell you a little bit about Taraxa, the project, as well as some of the applications that we're working on. Okay. So quick introduction. We won't go into all the details, all the hype about IoT and blockchain, but I'll just say that there are several very interesting problems that we're trying to solve within the IoT ecosystem with decentralized ledger technology. So the first one is very, very short term, right? So the short term problem that we're seeing today is that we have a lot of business models in the world that actually their viability depends upon a basic level of trust for data generated by devices, right? So we'll give you some examples later. But without this trust, these business models become less viable. There's more friction in the business, all kinds of problems. So that's one short-term problem that we're addressing. The longer-term problem that we're addressing is that as devices become increasingly more autonomous, and as there are more and more of these devices, of course, centralized governance systems don't really work that well. They don't scale well, and they're less secure. But this idea of autonomous machines flying around, making our lives better or governing over us, whatever it may be, that's probably a few decades away. So this is a much more longer-term problem. But these are some of the fundamental problems that we're addressing. So what can decentralized technology do for IoT devices? So first of all, it can give devices unique identities. Right? So devices don't have identities like you and I do. Right? So devices only have identities within a very small ecosystem. Right? So within a device's network, people know what that device is. But as soon as this device leaves the network, it has no identity, it has no reputation, right? It's as if I am Stephen Pu in this room, but when I go outside, I get arrested because I'm the illegal immigrant, right? No one knows who I am. So that is not very great for devices, and I think blockchain can provide that. The second one is that devices can start having the concept of asset ownership. They're able to own assets, and they're able to trade assets, right? And the third one is that because they're actually able to perform economic decisions and perform financial transactions, they're actually able to govern themselves and become a lot more independent. So today, devices don't make economic decisions. They only make very smart localized interests, right? They can say, oh, is this a cat or a rock? Right? They can say that. But they can't say, well, I'm running out of batteries. I need a software upgrade, right? Where do I get that? Who do I pay to get that? Those decisions are not on the device level. Those decisions are made by students. And because we are, because we want to achieve these goals, we're created a layer 1 ledger specifically designed for this. Today, I won't go into too much technical details unless we can ask about that during the Q&A or after the event. But we are using a block DAG structure with a very fast finalization. It's an asynchronous process. We're doing concurrency inspired by software transactional memory. So we're trying to make sure that transactions on the blockchain are actually executed in parallel rather than in sequence. We're using fuzzy sharding, which is a set of technologies that we came up with to make sure that we can actually make sure that the network is able to coordinate itself in terms of block production, in terms of transaction jurisdiction without coordination between them. We're also in the process of making trusted light nodes as well as an adaptive protocol. I can go into more details if you guys are interested, but today I'll primarily talk about some of the applications. Actually, just yesterday we released the second version of our testnet. So if you guys are interested, you can go check out the documentation at Taraxa.io/docs. You can scan in this QR code to join our Discord for a discussion about development. So one of the near-term interesting that happened with our project is actually we actually have a very substantial presence in Japan. All of our applications today are deployed with Japanese clients in Japan. We recently co-authored a book with UAT, which is a subsidiary of METI, the Japanese Ministry of Economy, Technology, and Innovation. This is the first book on blockchain published by the Japanese government. And on October 7th, there was a government-sponsored symposium talking about blockchain. This is the first government-held event on blockchain in Japanese history. It was attended by over 400 corporate executives as well as policymakers. So we're very honored to be partnered with the Japanese government as well as seeing that they're very friendly to blockchain technology as well as cryptocurrencies. All right, so let's talk about applications. So the first application I think is actually very stereotypical of the use case I was just talking about, right? So we're working with one of the largest arcade leasing companies in Japan. So their parent company is actually the largest retailer in Asia. Whatever the arcade machine makes, let's split the profits, right? Very, very simple. This works really well in Japan because apparently in Japan everyone's very honest. Their customers actually tell them how much money each machine is making. They have been trying to expand globally into other countries, and as soon as they expand overseas, they found out that not everyone in the world is that honest. Right? People don't report accurate earnings to these machines, and their revenues are suffering. So they're trying to figure out what can they do, right? So our solution is very, very simple, right? So you install a wireless module into these machines with a secure element for signatures, and then upload the data into the cloud, right? So far no blockchain. So great, this is a pretty good solution, right? Except if they did that, then their distributors or customers, they're going to ask, where'd you come up with that data? You should make it up. Where's the proof that this data actually is legitimate? So this is where blockchain I think becomes very useful, is that we also need to have each machine having a unique set of keys. It will sign, and it will also hash the data that it collects and put the hashes into the blockchain. Right? So this way, you can get some level of consensus across these different partners that the data was indeed came from these specific devices, and that the data hasn't been tampered with after they've been collected. Right? So the distrust is very endemic in this business. Right? So the lessor distrusts the distributor distrusts the customer. Even on the customer side, the management distrusts the operations of people. Right? So at the end of every day, at the end of every week, at the end of every month, numbers don't match up. Right? There's also so much suspicion on who's stealing how much money where. Right? So this is a very, very interesting solution. This is actually one solution where the customer is contacting us on a daily basis. Like, is it done yet? Is it done yet? So we're working overtime to make sure that they actually have over 20,000 orders. So our average order size is like 10 machines. So they have over 200,000 machines that they're waiting to rent. They're afraid to rent it, okay? because they know that as soon as they rent it out without some kind of mechanism like this, they will be losing massive amounts of money. Very interesting. The second collaboration, we're working with the largest automobile maker in the world, actually, also in Japan, of course. So the current way all these big companies work with data is very typical, right? So they get all the data, they don't tell you about it, and they make money off of it. That's simple. So of course they see the writing on the wall, and that's not going to be very legal in 5 to 10 years. So so they're worried. They're not extremely worried, but they're getting worried. They're getting worried that all their current data-driven business models based on mobility data are not going to be legal, right? Pretty soon. And so what do you do about it, right? So first of all, you have to have a mechanism that assigns data ownership to the drivers, to the vehicles. You also run into the same problem of validating these vehicles, right? How do you know that data came from a car rather than it came from some random number generator sitting somewhere? And you also have to make sure that you have a way to validate the data, that it came from the right sources, that it was immutable, and deploy them in a variety of decentralized use cases. Right? So some of the use cases that we're looking at for that, number one is a decentralized storage of odometer and accelerometer data for second-hand car sales. So for those of you on Twitter, hopefully you can finally hear me.
We're going to Twitter Live, so that's why with Twitter Live, people online can listen to Stephen clearly.
I think I have to speak very quietly. So some of the use cases that we're looking at, right? Number one is anchoring odometer and accelerometer data for used car sales. Because when I'm buying a used car, for example, the only really thing I care about is mileage and whether or not there's been any major accidents, right? So today, every single time I buy a used car, guess what else I have to pay for? I pay $40 to Carfax for a report, right? It's like the Carfax tax, right? You can't escape that. And of course, that report is not that accurate because they only rely on self-reported data. If I got into an accident with someone else, I'm going to try to settle it privately so no one else knows about it, right? There's a ton of that kind of stuff happening off the records. So here we have a system that can actually guarantee that that data is properly anchored into the blockchain. And I don't have to sell that data for very much, for example. Sell it for $5, $2, whatever. The cost is very low. So you have a very low cost, a very disruptive technology actually entering this market, this vehicle history report market in the US alone is around $1 billion annually. Right? So that's just one of the many things that we can work on. Right? All right, so let's get the third one. This is interesting. So we're working with this very large heavy equipment manufacturer in Japan. So they, of course, like most companies in the world today, have a global supply chain. Okay? So and the problem that they're running into with the global supply chain is very simple. Is because today in our modern globalized world, business has reached a level of complexity that has defied the management of centralized systems. Right? So typically, what happens is that if I'm a company working, I'll create my own little set ERP software. I'll force all my suppliers to get on that software. Right? Great, problem solved. Right? This is a great solution. Well, guess what? Today, your supply chain is 10 layers deep. 30,000 large. Every one of those suppliers working 1,000 other people that they work with. They're not all going to install 1,000 different pieces of software. Sorry, that's not going to happen. Right? So you end up with tons of delayed orders, wrong orders, change orders not being fulfilled, legal litigations. Anything that happens in the supply chain drags on for very, very long. And the worst thing is that because we're still working with a centralized mentality, any error or discrepancy in the system is looked at as a failure. Someone's KPI is not being met, that guy's getting fired. Right? So you have lots of problems, and you have entrenched interests to not recognize these problems. Right? So these are very, very interesting managerial challenges that shows that how centralized systems fail in increasingly complex and globalized systems. Okay. So what's the solution, right? Well, the solution is you define a set of very loose open standards, right? You get every player on the network to define their own inputs and outputs. Do not enforce these standards with an iron fist, because if they're 2 layers away from you,
they don't care about that. You don't get to enforce their data standards, right? They define their own localized data standards. They work with their localized set of collaborators, and that's it. That's the best you can. That's the best you can do. The age of forcing everyone to get on a single system is gone. That time is gone and past. So now you have to rely on a decentralized system with open and loose standards, where everyone can work together in a much more frictionless way. It gets deployed very slowly, but it turns a very large and impossible problem, which is forcing everyone, all their 30,000 suppliers to get on a single system, into many smaller, easier to solve problems. Right? So this is a very, very interesting solution that we're working with. All right, last one. Cooperation. I was very surprised to find out that's actually a word. I thought I made it up, but that's actually, well, it's a word according to Google, right? So competitors collaborating, right? It's very interesting. So we're looking at the parking market in Japan, right? So the parking market in Japan is very interesting. So in the city of Tokyo, for example, there are hundreds of parking operators, hundreds of them, okay? Well, what's wrong with that, right? Well, what's wrong with that is, number one, if I'm somebody with parking inventory, right? I'm a real estate developer, I'm a shop owner, whatever. I got parking space and I want to rent it. I have to only pick one. I can only pick one guy to manage and sell my parking inventory. What happens if I pick two guys? Well, guess what? I put my asset here, I put my asset here. This guy sells it, the other guy doesn't know about it, right? You get conflict. This is a classic case of conflict, right? Well, how about I just create a centralized platform where I go to every player and say, hey, y'all synchronize data with me. Right? So we tried that many times already. Guess what these parking operators say? You think we're idiots? We're all going to give you our data? Are you going to own us? Right? You're going to kill us, right, with your centralized system. So the market stays fragmented. It doesn't consolidate. And customer experience on this two-side market is very, very bad, right? So on the supplier side, inventory side, they don't get a lot of choices, and they don't cover the market very well. On the driver side, are you really going to install 30 apps on your phone just to park in Tokyo? No, you're not. And you're going to end up installing nothing. Okay, so bad user experience on both sides, right? So this is a very, very interesting thing because we're using these magnetic sensors to place at the entrances to parking lots, as well as on every single parking lot, right? To actually account for whether or not there's a car parked on top of it. Very simple magnetic sensors, been around for a while. We're some LoRa. Japan has 96% LoRa coverage. We have our own gateways we can deploy. Very simple, right? So once these sensors are deployed, by the way, even without blockchain, these sensors help raise parking inventory utilization, so it makes money for them even without blockchain. Then the second thing to do is that you have these sensor signals and you actually start anchoring them onto the blockchain, right? So now you have a decentralized collection of scheduling, right, of which parking spot is available and which parking spot isn't available. Very, very simple, right? And this is the way to get competitors to collaborate without really collaborating, right? If you don't like it, get off the system, right? If you want to fork and copy the system, go ahead. It's all free. You can do whatever you want, right? And this, at the end of the day, it creates a much more unified experience for both people with parking inventory and on the driver's side. Right? So we're working with the second largest parking lot operator in Japan to deploy this system. It's very interesting. And notice how I said that this helps them make money. It's very critical. Right? If you walk into a client and the first thing you say is blockchain, you kiss that client goodbye. He's not going to talk to you again. So you'll waste 3 hours explaining what blockchain is. He's not going to get it. You're not going to get a second meeting. No second meeting. You're gone. Right? You walk in the door and say, hey, I can help you make more money. Want that? Got it. Everyone's interested in that. Right? Let's deploy these sensors. Let's give you 30% increased asset return on investment on your parking lots. Everyone loves that. And once the sensors are in place, we want to take it one step further and make this a very big national system where you can work with your competitors. Why not? Right? The sensors are already in place. Just a small switch, turn it on. Okay? So this is another one of the interesting projects we're working on. So all of these use cases are in Japan, I think, for a pretty good reason. Japan has very clear and very friendly regulations to cryptocurrency and very clear and friendly regulations to blockchain. Right? So if I go to a US company and I start talking about blockchain, and they're going to talk about, well, what is my accountant going to say about me holding coins? What is the IRS going to say? What is the SEC going to say? If I start giving them coins, I go to jail. If I sell them coins, I go to jail. If I give them coins for free, I go to jail. Right? So all very bad options. Right? So Japan is really one of the only large economies in the world that has a very friendly policy towards blockchain technology as well as cryptocurrency that enables these business models to work. Right? So it's very, very, it's a very, very great market. How much time do I have left?
Yeah, so.
It's been 20 minutes already?
Yes.
Okay, all right. So I'll shut up and let some of the other illustrious speakers talk about their projects. Come find me later if you find anything that I said remotely interesting, or if you think I'm full of bullshit, you can copy that to my face as well. So great talking to you guys.
Thank you very much. Thank you for the intriguing introduction about Taraxa and its applications now. So we want this meetup to be a very conversational exchange. So feel free to raise your questions during our panel afterwards or after each speech, so that you can communicate and raise your questions. So the next speaker, I will introduce you Xiaozhou Li. He's a co-founder at Celer Networks. So Xiaozhou received his PhD from Princeton University. His works have been published at premier venues in distributed systems, networking, storage, and data management, and have become core components of Google's TensorFlow, Intel's DPDK, and Barefoot Deep Insight. Let's welcome Xiaozhou.
Hi everyone. So I'm from Celer. In Celer, we do layer 2 scaling platform and decentralized application framework. I'll describe, first I'll talk about our adoption vertical on the gaming industry, and then explore more about the under the hood technologies. Since the format is a bit off, but okay, so yeah, at Celer we have our product, a real product in production to serve real users, a lot of users. Our core product is a gaming platform currently called Taraxa. It is available on Google Play and iOS App Store. It's actually the first decentralized applications that you can download it from the iOS App Store that allows you to play blockchain games. And we provide a very easy, simple to use development SDK to let users quickly integrate their existing game with blockchain, and provide also web SDK for users to quickly develop their own decentralized applications. So further shows the data. Currently we have a lot of users. We have users across 89 countries with many millions of dollars in crypto, real cash spent in these days. And we have more than 12,000 monthly active users with more than 300,000 games played. So this may not be that huge if you compare to the traditional gaming like Tencent game projects. But this is huge in the blockchain industry, and we firmly believe this is a very good start to push the blockchain gaming into real massive adoption. Wow. Keynote. So The common question people may ask is, what do I need to learn to know about? If I'm a developer, what should I do to integrate my existing Flappy Bird or whatever app into blockchain? Do I need to have deep understanding of blockchain technology? Do I need to write the smart contracts? Do I need to manage all the sensitive user private keys? And our answer is, of course, no. This one. No. This layout was beautiful. No, I didn't make it. So yeah. So we provide our Celer game development framework for common daily app developers. To integrate your HTML app into Celer Network, you need zero knowledge about blockchain because we take care of all the blockchain stuff with you, and you only need to send 2 lines of code. Just add 2 lines of very simple code to hook up with our systems. Then you can make your game into a skill-based competition game, like the 2 players match on each other, and the loser pay winner, agree the bad fees. All this we will take care of. And the numbers now we have is we just started very recently and already have 260 developers supported 100 games. And for the first time to integrate those HTML game into our platform takes less than 30 minutes. And we also provide a Celer web SDK. It's a more low-level SDK that allows users to build your own DX, other types of applications like financial trading stuff, virtual exchange, or micropayment services. And when using our SDK, you only need to focus on your application logic. You don't need to worry about anything about the underlying scaling. I'll talk about how to scale your application through layer 2 channel technologies. But this you just need to know about it. There is this thing, but you don't need to program it. We take care of everything about it. Okay. So as I said, we do layer 2 blockchain scaling. So what is layer 2? Let's step back a bit and talk about and recall that I said that we provide so many such a great gaming infrastructures for users to play so many games. But how do they do it? I just recall one interesting thing that when we did our first promotion, so we all know that blockchain is slow, right? When we did our promotion, like our marketing folks posted on Reddit saying that do you want to experience gaming in blockchain? We will give you great blockchain gaming experience. I really like one of the comments saying that, okay, I can experience blockchain gaming by adding 1 second the code, 1 minute the code in every move in my gaming. Right? So that is basically like in people's mindset how slow the blockchain is. So this is a fundamental issue that is preventing blockchain technology to develop to become to mass adoption. You need to give people something that says that it's you need to give people something that is it's trust-free, it's secure, but similar user experience. You cannot give people for user get users. Okay, you don't need to trust others. It's secure, but it's so damn slow. So that is because I didn't make a slide, so I actually don't know what's the next one. Okay, yeah. We're talking about the layer 2 101. So yeah, what is layer 2 scaling? It's basically on top of this layer 1 main chain blockchain, like using Bitcoin, Ethereum, Taraxa. These are all layer 1 blockchain. This provide with a great feature of cluster-free, decentralized, and but it is slow. Why slow? Because when we talk about blockchain, we always talk about the term consensus. If you think about from the traditional distributed systems background like me, once you hit the term consensus, the immediate next term you think is slow. Because consensus is fundamentally slow. You need every node to agree on everything. That is fundamentally slow. But that should not be how we build a real highly interactive, decentralized application for most common daily users. So we use this technology for layer 2 scaling. The main technology includes state channel, set chain. The core concept is to only resort to the on-chain consensus when absolutely necessary. You do most of your state exchanges off-chain, but still keep your cosign state proof with your counterparty, with others who are participants, and later only go on-chain when you do dispute. As the analogy of this current our normal social economic daily life, right? You can keep this blockchain as a secure core, as a law enforcement. So we live our lives safely because there are law enforcement. But we do not need the law enforcement, the courts to interfere with every single of our daily transaction activities. But what we do, like when we do business, we keep receipt, we keep contract, and if something goes wrong, we go to court to dispute. That's how our real world society scale up. And this is also should be how we build out the real fast decentralized applications. So because of this layer 2 scaling, our most interactions are independent only among the participants. So you still don't need to trust your component because every interactions you keep the receipt, you keep the cosign state proof. And it's also private, it also has more privacy because most of the transactions are only seen by the participants. So now I'm going to go some more of the So I'm going to explain some more about the under the hood technical details about how these things work. So we have, first of all, we have our open source protocol stack. You're free to download and take a look. So at a high level, we construct a layer architecture with a network of off-chain nodes. So these are these are all the nodes are connected through the state channel network. Our underlying is an on-chain smart contract that is like the Supreme Court, like the escrow to hold your asset and to handle all the dispute. And when people do interactions with each other, we just need to send this payment or send these interactions off-chain with the one who already has set up the channel with you. And for example, if it's a payment network, this payment can depend on very flexible condition interfaces, and it depends on the state of other applications. So we designed our center with extra focus on simplicity, performance, low cost, and flexibility. We believe these are actually the core features to achieve mass adoption. Yeah, in blockchain, of course, we take security and trust-free as a must-have return. That's not really there. But our point is that only secure and trust-free is not enough. The system is to be simple, to be fast, to be cheap, and to be generic. So at the very bottom layer of our technical stack is we call it the state channel. especially two people set up a payment channel so that you can quickly exchange the off-chain payments with each other without the interference or without the need to be witnessed by other people. So yeah, this slide is a little bit happy, but bear with me. So basically, this is the core infrastructure, core data structure about our C channel. This is the two participants that need to co-sign this tool, which essentially tells among the two of us how many assets do we have already, and how many payments have we sent to each other, and what are the pending payments, which is here. This is the essential part to allow us to build very generic applications on blockchain. So this pending payments, this mainly has two different two attributes. One is condition. What's the condition of these payments? So, for example, the payment only happens if you win the game, and what is like the application logic. And how do we resolve the payment? Like what happens when this condition results in some value? And this is just a quick diagram to show how do we send and resolve payments. For example, when we start some game, we just need to send each other like a conditional payment request, which is to co-sign a new updated state proof with a higher series number to include the conditional payments, and settle similar stuff. And if anyone is not happy with the off-chain behavior, thinks that its opponent is not cooperative, it can always go on-chain to dispute. As the on-chain smart contract acts as a secure core to guarantee that you are always safe as a last result. And of course, we do deep optimization of the coding to allow highly concurrent fast performance. So for the hop-by-hop conditional payment, as I said, our main goal is to simple. This is a full duplex so that the two peers can send payment to each other at very high speed. So for multi-hop network, so that was what I just talked about is just a single hop, like me and my peer has a payment channel. But I cannot have a payment channel with everyone in the world. So as long as we can reach some people through the network, we can send payments. So I think the time is a bit, I'll quickly go over the multi-hop payment cases. This is a simple example of the Boolean payment. For example, the payment only success if I win some off-chain games, like this is like a simple diagram, like how do you set up your payments in multi-hop? Like you only need to, actually as a plan, you only need to be connected to one serving node, and this serving node will take care of all your interactions with anyone in the system. And to settle a payment off-chain similar graph. And so if someone is not happy with the off-chain behavior, thinks that anyone along the network routing path is not cooperative, you can always go on-chain to dispute. As I will be talking about secure, simple, cheap, and fast. That is our goal. And we also, in addition to the Boolean conditional payment, we also support numeric conditional payment, which means the payment result can be resolved with arbitrary value. This can empower more flexible use cases like second-class options, like this microservice, pay-per-use VT services, that we actually exporting. So what we are currently focused is on this underlying very generic infrastructure, this layer 2 scaling platform that will empower user developers to scale their applications, to build their decentralized, trust-free, secure applications to meet the need of common data users who are also required operations to be fast and cheap. And of course, and our architecture is very flexible, can be extended to other techniques very easily as well. Okay, so the key takeaways. So we hold our design principles from our lessons learned of building real large-scale production systems to automate the trust, to be secure and trust-free, to minimize the on-chain cost, to push the complexity to the edge, and to minimize the off-chain communication overhead. And we're empowered by a layered decoupled architecture with the end-to-end principle allows it to easily scale out. And we are blockchain agnostic. Our data structures can be easily extended to other blockchains, to various layer 1 blockchains. And we have zero downtime upgrade, which is not very easy for most of the blockchain systems. And our architecture is flexible enough for the future applications. The final note I want to emphasize again is that we believe in order to let blockchain applications to reach to mass adoption, we need to focus more on the cost, on the performance of the application system. Of course, as I said, security is a must-have, but it's not enough. That is what we are currently working on to make blockchain decentralized applications not only secure and trust-free, but also fast, cheap, and simple to use. Thank you very much.
Thank you so much, Dr. Li, for your presentation. And sorry for interrupting. There were some problems during the presentation about the PPT slides. So let's welcome our third speaker, Sam Abbasi, tech evangelist at Algorand. So Sam is a technical evangelist working on developer relations at Algorand. Sam co-founded and led Bushido Lab, a cryptocurrency and blockchain development company out of Miami, FL. He currently teaches blockchain and cryptocurrency fundamentals at Miami-Dade College. Sam has a bachelor's degree in economics from Loyola University, Chicago, and a background in neuroscience from the University of Miami's Miller School of Medicine.
sorry, everybody. So yeah, my name is Sam Abassi. So it's my first time in SF, and it seems like any room I go into, I have like the least impressive accolades at any given. But anyway, so it's building blockchain infrastructure for practical use cases. So first I'll start with what we're going to be doing. So I'll talk about what Algorand is to begin with, and then what our new features are that enable these use cases, and some examples of what's happening currently. So what is Algorand? So Algorand is a permissionless blockchain. There's minimal computation required. We have enterprise speed, so 1,000 transactions per second theoretically at our threshold, and less than 5-second block time that we're also trying to make faster. And there's instant finality. There are no stop forks. And what that means is that obviously someone can fork the code base, but we're not longest chain dependent. So we're not proof of work driven. So you can't once a transaction is committed inside of a block in the Algorand blockchain, then there's simply no way for that to be taken back. Different from other models. So we have a worldwide mainnet network running. We have a testnet and a mainnet. Our mainnet nodes are made up of a combination of early backers, academic partners, and other institutions, and people just running nodes in the first place. Our node structure is interesting. We have two different types of nodes. We have relay nodes and participation nodes. The relay nodes effectively right now are only operating as relay messaging, or relay messengers, in the sense that they don't run protocol, they don't run consensus, they simply are there for sending messages back and forth between different nodes. There's also no incentive to run a node in Algorand. Similar to Bitcoin in that sense, there's simply the implicit understanding to maintain the integrity of your own financial transactions by running a node on the network. But it's not like a Dash model where you get a payout for running a node. Now these things may change, and probably will change as the network develops, but as it stands, that's currently how it works. Just to give you an example of what use cases people are thinking about and what people are doing. Algorand, like every, player in this space, is constantly in some kind of identity crisis with the specific message in mind. And ours, I think, kind of goes hand in hand with the financial world. So, as an example, a couple weeks ago, I was in New York with Barclays, and they had what was called Derivac 2019, so derivative attack, alongside Bank of America and a bunch of other banks. And the objective of that was, so the problem is that across the world's financial system, there are daily discrepancies between financial institutions' databases. And that needs to be reconciled. So it's effectively consensus by reconciliation. The problem with that is that it's expensive, it's error prone, and it generally slows down global commerce as a whole. So the goal of this hackathon, as a use case example, was to show how the ISDA common domain model for financial assets can be implemented. ISDA is the International Swaps and Derivatives Association, and the CDM is supposed to be like the blueprint for how derivatives are traded and managed across a trade's lifecycle. So you'd have a single common digital representation of derivatives and trade events and actions, and this should enhance the consistency and facilitate interoperability across firms and platforms. So that's what CDM is, and hackers during this event were supposed to figure out how to use that CDM model on a type of blockchain. And I guess I should say that, well, back out. So the 7 different challenges that they had, that they could pick from, and they could pick a combination of these, were trade execution, allocation, affirmation, confirmation, settlement, portfolio reports, and posting collateral. So the winners were of a team called Digital Bull, and they used Algorand, and they were the winning team. And this was their solution. So their solution, it was modeled in a way that every financial institution would have to have an independent database. So holding JSON objects to represent details of each use case. So in the portfolio report use case, which is the one that they used, so number 6, what they wanted to do was have the clients obtain a report of which trades have been executed and which trades have been settled. So the workflow that they designed basically creates a CDM input object from a JSON file, which is happening here. Then step 2, you have to process a CDM input object and then create a CDM output object. So the input object could be like the execution of a trade, and then the output object could be a report describing the settlement of the trade. Then you go on to step 3 here, which either it validates it, so it fails or passes. If it passes, you then commit a hash of the object, which is effectively a global key, and the Algorand ID, alongside the CDM event, which is in accordance with this CDM rules. And in that sense, here in this step, you're actually leveraging Algorand's infrastructure, because what you're doing is they were committing the CDM object into the node field of an Algorand transaction. So the way our network is designed as it stands is that you have a transaction object with the standard parameters from to transaction fee, block bounds that define its validity range. But also you have a node field in any transaction that allows you to write a kilobyte of data, so you can effectively run anything off-chain and then commit it inside of a transaction, just being like a timestamp utility. So that's what step 4 was. And then in step 5, you store the CDM object output together with the Algorand transaction ID that committed that object to the blockchain into a data store in JSON format. So now you have a financial event that's been validated across the blockchain. This is, you know, apart from the gaming aspect of blockchain, there's more fun things that we can do. This is kind of a more real-world, institutional, boring example of what some real use cases can actually produce. So now I want to talk about the new features, and they're layer 1 features. And we just had a great presentation about what layer 2 solutions can offer, but I want to talk about why certain layer 1 functionalities might be important for designing a network. So why is layer 1 so important? Tools implemented at layer 1 avoid the complexities, the expense, and security risks of smart contracts as we've seen in Ethereum. So layer 1 functionalities have the same security, efficiency, and atomicity as single payment transactions. And when we talk about security, we mean that because it's a layer 1 transaction, or because it's offered on layer 1, it offers the same security principles that anything else on layer 1 would offer. So the 3 main features, and these are brand new, so we're releasing these, they're on a beta net that I'll show you later on. But these 3 brand new features will be released in November. So this really should be kind of a game changer for us, to be frank. So what finance use cases can these 3 features enable? So obviously sending money, simple payments, we can already do that. But issuing new currency, creating digital assets, purchase and selling of digital assets, trading them, exchanging currencies, loyalty points. I mean, a lot of these things, if you've been in the space for more than a year, you've probably heard a lot of the same things again and again and again, because a lot of the same things can be solved by this theoretical blockchain. So they can group payments, setting up periodic payments, and making them alone. Yeah, so, and by the way, just to be clear, we will be offering layer 2 functionality, just not now. Our project is made up of academic heavy hitters, and it's incredibly academic in how things are done. So we have an entire theory team, and in that sense, development is very methodical. So we will have layer 2 functionality, just not right now. So with respect to the first feature, which is Algorand standard assets, it goes into fungible and non-fungible tokens. And just to give a summary, if anyone's not familiar, fungible tokens are just things that can be traded, or things that are equal value. So a dollar is made up of 100 pennies, all those 100 pennies are equal value. Obviously, CryptoKitties or any kind of playing cards are NFTs in that sense because they're unique. So fungible tokens are the basis of, several financial applications. So currency, again, loyalty points, and more interesting, shares of an asset or securities such as stocks, bonds, and derivatives. So on other blockchains, these are typically done using smart contracts like ERC coins. So what Algorand standard assets are. So in this framework, any user can create a fungible or non-fungible asset. They can define things like the potential supply. The asset now has several different features. It can be freezable. As an asset manager who, at least at the beginning, is the person who creates the asset, and this can change later on by delegating responsibility, they can make units, burn units, freeze or unfreeze the asset, and you can only freeze the asset if it was designed to be freezable when you created the asset. You can't now retroactively freeze something that wasn't supposed to be freezable. You can remove It's units from circulating supply. You can destroy the units, and you can do things like we termed it clawback, but you can call it whatever you want, where you can, again, take an asset back from an account if need be. And all these things are transparent in the sense that whoever is servicing or managing the asset has, they can see all of this. So none of this is actually a surprise. And I think, importantly, the asset manager can also forego or renounce any of these privileges at any given point. So for a lot of financial instruments, this really does go hand in hand. The next major feature are called atomic transfers. So these are irreducible batch transactions and they're group transactions. So you'll be able to send any type of asset on Algorand, whether a non-fungible token or a fungible token, the same type of tokens or not, in one go, in one transaction, so they're completely atomic in that sense. And this should, in theory, eliminate the need for HTLCs, at least for now, on layer 1. You won't have to have that step-by-step process where you're generating a value, generating a hash, or a contract, and sharing that between multiple different parties within a certain time frame. You can now do it in one go without any counterparty risk. And the reason why that's important is because non-atomic trades, this was here, the non-atomic trades equal increased counterparty risk. So, as an example, if I send Bitcoin to a stranger, and I hope that they send Litecoin back to me, that's a non-atomic trade. It's not instant. Atomic in computer science simply means that an event proceeds in a way that was planned or it doesn't. So in this case, an atomic trade either proceeds where all of the assets are being traded to the respective parties accordingly, or they don't. And then the last big feature we have is Algorand smart contracts. So these are layer 1 smart contracts that automatically enforce custom rules and logic, typically around how ASAs, so the assets that you can define and architect, or algos can be transferred. So they're intended to provide a logic-driven way of applying transactions. And with ASCs, the user can delegate their signature authority to others or set up some sort of like escrow-style account where logic determines when tokens or assets are removed from escrow. So, well, this is an example. Well, this is just a quick example. So you can concatenate several different transaction files into one. You can then run, so Goal is our command line tool. Clerk is one of the commands that allows you to just do different things with respect to a transaction, sign it, write it to disk, or whatever. So you can group the transactions together, you sign the transactions. There's a typo, this should be the same as this. Signout.tx should also be signout.tx. Here's where you actually send the transaction. So that's just a very quick example of how an atomic transfer would literally happen, at least in terminal. And then you write ASCs in our scripting language, which is called Teal. This is newly developed Teal. Teal is a transaction. It stands for Transaction Execution Authorization Language. It's bytecode based and it's a stack language. So it consists of 30 basic instructions and it's a straight line program solely using Teal opcodes. So this is very similar to Bitcoin scripting. And by the way, when I talk about ASAs, that should sound familiar in a sense. At least, it should sound familiar. That's effectively colored coins, and colored coins come from Bitcoin, right? And it's funny seeing these things kind of come full circle. There was a talk at the conference yesterday, and I forgot who it was on stage, but they were talking about the whole cliche thing where you had companies during the dot-com boom who had these ideas that were way ahead of their time that crashed, and then were remanifested 10 years later, like Instacart. I forgot what the dot-com boom company's name was that crashed, but they offered online grocery services, and they just flopped. But now Instacart shows up 10 years later, and the infrastructure is now ready and designed for that to happen. So it's like if you had the idea to have video streaming back in '94, that wouldn't have made any sense because it wasn't the infrastructure for it. But then now we have Netflix, right? So in this sense, this is interesting because everyone was excited about the idea that you can now represent assets natively on Bitcoin using colored coins using Bitcoin script. And then that died, and ERC20 and ERC21 tokens completely dominated the market back in 2016 or back in 2017. And now that Ethereum is kind of dying, we're seeing a resurgence of more traditional, primitive asset representation like this. Every ASC can also be 1 kilobyte long, and this is to retain the integrity of our Algorand transactions. the most important thing is to make sure that we have our security principles in place and that we have our speed. So remember, every transaction has that known field that can hold a kilobyte of data. So in this case, our smart contracts are also a kilobyte long. And so Teal, so if we, just to show you kind of quickly how it works. So if we define an ASC's simple computer program as P, P is just a sequence of instructions from the Teal list, from the Teal opcodes, a list of opcodes, to be executed one after the other. There's no loops, there's no go back to instructions, and there's no retained states. So if P consists of K Teal operations, then each execution of P produces an output by performing no more than the same K operations in the exact same order. And this is kind of what it looks like. So again, if you're familiar with Bitcoin script, it's a bytecode-based stack language. It's pop on, pop off. You're popping things onto the stack, you're popping things off the stack, and you're running operations while you're doing that. So it's similar. It returns either true or false. It's very simple. And we have supports in the SDKs to run specific templates to make it easier for developers to build this. As an example, escrow limit withdrawals, split withdrawals, periodic payments, limit orders. And this is an example of what an Algorand transaction now looks like, where you can replace the signature with a multi-sig, or now with Teal logic because it runs inline. And what are some use cases for Algorand smart contracts? Post and selling a trade of transactions, securitized loans, crowdfunding, and accredited-only transactions. And I mean, I think the post and sale transaction is probably the most interesting where you enable any other user to purchase an item at your given price, and that's all you have to do, and it will execute based on the logic. You know what? I don't have the other slide, but we just released our beta yesterday morning, actually. So now, if you're a developer, developer.algorand.org, you can go and test out all these 3 new features on our beta net. And the way it works is that once these features go from our internal dev net, they then go to beta net. Once they're tested in beta net, test net, and then main net. So if you'd like to test these new features out, they're available now on our brand new beta net. But yeah, those are new features and those are Algorand's use cases. Thank you.
So now it's time for our panel discussion. So let's invite Celer Networks from Algorand, and also Xiaozhou, Dr. Xiaozhou Li from Celer Networks, and Stephen Poole from Taraxa to go on to the stage. Okay, so the first question.
Actually, if you guys have any questions, feel free to raise your hand and ask them. It should be great. There's a question right there.
So, do you touch any specific devices? Like, do you have like? Do you touch any specific devices? Any microcontrollers, anything like, is it end-to-end security important for you, or you just don't have like, it's a general that you are touching IoT, not any family of specific devices, something like that?
Okay, I want to answer that first since it's IoT related. We're not targeting anything specific. So we are interested in making devices more useful and more autonomous in general. Right? So depending on the application, we choose the best device to go after. Our plan is basically to make sure that blockchain gets on devices, any devices, as many of them as possible, and as quickly as we can. Because if we're going to realize the future vision of highly autonomous devices developing their own internal economies, these type of mechanisms needs to be installed on them, right? So I think for us, because my first startup I founded was actually an IoT startup. We were making wireless sensor networks. For as far as IoT or devices go, our current challenge is not putting blockchain on devices. It's actually putting devices into businesses, period. So that's always been a very, very big challenge. So we have a lot of hurdles to go through. So we try to solve near-term problems, generate value for our partners, and use whatever device that fits the current situation and make sure blockchain's on it, adding value.
Is there any other questions?
For the gentleman in the middle, it's a great presentation, sir.
Thank you.
I wanted to ask you about the platform. Now, when you're allocating discounts to messaging services, are you using anything such as your federal clearing strategies using QM or TPMP messaging services?
This is the beginning of that. When you're doing what?
I want to know more about the dynamic messaging, which validates the security on the services.
On the servers themselves?
Yes, on the services, the medical services, and the stamping.
Oh, the timestamping.
Yes.
How the messages are relayed back and forth. I'm not.
The geolocations as well.
Of the nodes themselves? So the nodes, so in order to, you have to turn on what's called telemetry to have any kind of data log. So it's difficult to know at any given point how many nodes are on the network or where the nodes are, because not everyone has that turned on. With respect to how the messages are relayed back and forth, I don't specifically know technically how that's happening, at least on the messaging side, but I can get your contact and get back to you.
So if you have questions, please raise your hands.
So this question is for Sarah. I was looking into robotics and AI, and I think that's not related to IoT. Do you have any already production level use cases in industry?
So right now we don't have any partners in robotics per se. We are, like I said, we're working with asset management sensors, working with automotive sensors. We're working with sensors that are involved in logistics and supply chain. So these are the things that we're working on. Robotics. I'm not sure. Do you have a use case that you're thinking about, or do you have a pain point that you'd like to solve in robotics?
Yeah, so we have a partner. They do education robots, kind of human to teach. That's kind of for this particular case.
So what's the pain point? What's the problem we're solving here?
So the pain point is, if, for example, you have teaching as a robot, right? Maybe use blockchain and only the content that's go every time together. Then we can take a real-time payment. That would be one solution, and also the other one is based on how much time and what level of teaching, and then you can have kind of automatic payment.
Okay, so it's very similar to the asset management use case that we have. Yeah. So the solution itself is very simple, right? It's basically first of all, we're not using blockchain for payments because this is not really because of technology. This is mostly because of regulation. Most countries it's not legal to use it as a form of payment. But so right now, we're primarily using it as a way to keep evidence, right? I think think that's a little similar to the use case that you were mentioning as well. It's basically how much this device has been used can be securely and proofly stored, so that later on you can, when you issue a bill to somebody, you can say that, hey, we have proof. This is how long this device has been used, how many lessons they accessed, and the proof is we have the data. If you don't trust our data, you can look at the blockchain to make sure that this data matches the blockchain, so that it works really well. Right? So I think that's a way for, in general, for asset leasing. Asset leasing is, I guess, the new fancy Silicon Valley word for that is shared economy, right? It's basically everyone using the same asset. So yeah, so we are working on a solution, I think, that would resolve that problem.
So if let's say we work together, then I need to find another solution, basically to find my own payment on top of the Algorand's solution.
Yeah. So first of all, yeah, we don't deal with payments. Once again, it's. I think you guys probably have more to say about that, but we're trying to make sure we stay within the boundaries of regulations. Yeah.
We do payments.
And we don't know.
You're more courageous. You're more courageous.
Making a consortium blockchain.
So I have a question for all of you three. There are so many blockchain projects recently. So what's in your opinion constitutes meaningful differentiation? So what differentiates your project from others? So something that helps them to win in the market. Could you just tell us? Yeah.
Yeah, it's tough. Like you would think it's. You would think it's partnerships, right? That would be the most intuitive thing, where you have the right people on board, or you have the right companies that are talking to you or working with you. But at least in my opinion, we've seen Celer, and they've announced a slew of partnerships. Not really much effect, I think. The most recent one was with IBM. So IBM released this project. It's called Blockchain Worldwide, I think, or Business Worldwide. Basically, it's supposed to be Swift, but IBM's behind it, and they announced that Celer would be the blockchain they would use, but there wasn't really much movement in the price. There wasn't really, I didn't see much excitement except for their own internal comms. So you would think partnerships, but I don't think that's necessarily the case. And then you kind of go down to community, but again, and this is my opinion, but we see Ethereum hitting its limitations now, and they have the strongest developer community, but even that apparently isn't enough. So there's so many competitors. I think it ultimately, maybe I haven't lived the course of my life in this industry yet to have a solid answer, but I think it's probably like team and tech. I think you have to have the technology there to really deliver on whatever you're trying to promise, and you have to have the team to maintain that too. It would be tech and team.
Thanks. So I think from our perspective, the key differential is the technology, the team, and especially the ability to push to real production. Because we see a lot of people, smart people, have a lot of ideas, random ideas, but good random ideas, like when I was doing my research at PhD, but they never take off. So I think our main differential is that we have a very strong engineer team to design a system from beginning. We know that we are designing a system for large-scale production system. And we want to serve normal daily users who want things, as I said in my talk, to be not only secure, but also cheap and fast. But basically, it's our mindset to know from the very beginning that we are building real production system for common daily users.
Yeah, so definitely, once again, agree that team and technology obviously is very important. Blockchain work, I think we're in a time in this industry where the technology is so rapidly evolving, it's very mature. So I would say that what blockchain might look like 5 years from now it might very well not look like anything we're doing today, right? So I think in that sense, it's very important to have the right team in place so that we can constantly innovate and adapt. And I think that's something that I think we're very fortunate to also have here at Taraxa. One of the other things I think this actually goes with what Xiaozhou said is that when we go out and work with our customers, we make sure that they're making money from our solutions, right? We are actually helping them becoming more profitable. Either they're bringing more business or we're reducing their costs or something. Because only when you bring real value, right, things that shows up on the at the end of the day shows up on the balance sheet, right, then people are going to be very skeptical of your technology.
Thank you. I think we have gentlemen.
Hello. So, in 2019, now the last of the year, where do you see the opportunities to actually acquire or invest blockchain and IoT companies?
So, once again, because we want to stay within the bounds of regulation, I'm not going to talk anything about investments. But I think that the intersection of IoT and blockchain has a huge amount of potential. Right? Has a huge amount of potential. So I mean, IoT technology, because I come from a hardware background, so I really feel the pain of people who work in hardware is that it's really, really difficult to justify the deployment of a large and expensive hardware network. I've had so many challenges explaining to people why they should do that. And the reason is very simple, right? I mean, the clients are deploying these networks and they're not seeing a return on it. They're not making money out of it. Right? So blockchain, I think, is very, very interesting because it allows hardware to start exhibiting characteristics that it didn't before. Right, so it's actually making hardware a lot more useful. So talk to anybody who works in IoT, they'll tell you that a good 90% plus of the data that's collected by these devices, the owners and the clients have no idea what to do with it. Right? This is why IoT and connected devices, hardware deployments are going so slowly. So really look for projects, look for teams, look for technologies that are making hardware more useful. In that it's making more money, right? It's getting clients and buyers to have a good understanding of, wow, this solves a business need. Right? So it's a really upward battle. I mean, this is the reason why I got into the space is because I think that blockchain can really push the deployment and the proliferation of hardware and connected devices. That's why I got into it. So if you're looking at where the future is going to, look at teams and technologies that are making devices more valuable.
How long have you been in this space?
IoT space?
Yes.
I mean, I studied electrical engineering when I was at school, so that was in 2000, and my first startup was in 2008. So in IoT, so I guess I've been in it for over 10 years.
I just had a quick comment. I don't really have an answer for you, same thing, but just a quick comment. One of the reasons you probably got into blockchain too is because blockchain development is a lot like hardware in the sense that when you build software, you constantly iterate. You have an MVP model, you user test it, you iterate, but it's incredibly expensive to iterate on a distributed system. So coupling those two, I think, is fascinating. Actually, I don't really have an answer for you. The investing, I can't get investment advice.
That question brought me to the next. I actually have a question about the volatility in the secondary market today. So I just want to know that how does it impact your work? Like we know that you probably would not provide any investment advice, but how does the volatility of the secondary market impact your work when you dealing with your projects and to make it more practical?
I can start. So I would say it's actually not impacting our work at all because, surprisingly, our core team are not that into the daily crypto person. We actually, when we build our team, we are full technical background and we are interested in the technology. And we believe that in the long run, long term, it's something that will, it's something big. And we also realize that current price itself there's a lot of speculation on it. So we just decided to focus on the product. And actually, a lot of our core engineering team members, they only check crypto price once per month, something. So our way just to focus on the product and bet on the long run future.
Yeah, same. It doesn't really affect my day-to-day. So I'm in developer relations. Half the time I document code, then I write code, and then the other half the time I talk about it. And the people that I talk to are serious about building solutions. And it probably affects the ecosystem as a whole. There's tons of speculation, and the way to correct that is probably some sort of like regulatory framework around that, I guess. But it does negatively impact the ecosystem. There's more speculation, there's more people just bumping and dumping, but day to day, it doesn't really do much.
Yeah, I mean, I would agree with previous guests. I mean, the reason why there's so much volatility is because there's really no underlying. There aren't large-scale underlying businesses yet, right? So if you have a stock market, you have price and earning ratios, right? If there's no earning, then the price is just anything. It can be anything you want. So the space at large right now is basically still trying to find large-scale applications, right? So the right thing to do, of course, for any project team is to find those applications, add value, and the market will correct itself, right? I mean, that's really what everyone should be focused on.
Thank you. So, question for three of you. There's so many projects, blockchain projects around the world right now. So, how can you create enough traction to make a viable solution in order to compete with all traditional companies? Because right now there are so many projects. How you can target and attract early adopters to create enough traction for your project?
Yeah. So this is more of a business question, I think. So from my perspective, this is an honest answer. I think the market is wide open right now. I mean, this space is early. There's no Google or Facebook of blockchain. I don't think we're very far away from that. I think any win for any project is a win for the entire space. So I don't really see projects in this space as being locked into fierce competition. I really think that we're all working very hard to help the space gain legitimacy, help the space grow, and then help find interesting use cases that add value. What are we doing to do that? What we're all doing, I think, every day. We're building good technology. We're finding good use cases. We're solving problems for people, and that's basically how you should do it. When you're this early, this is like when TCP/IP was invented, and oh my God, how do I get a share of this internet market, right? Too early to talk about.
Yeah, I would say it's a business use, or the use cases on whatever network you're using. The more that you have, the better, honestly. Again, I mean, one thing I do like about this space is it's weird because, again, from the developer point of view, it's incredibly tribal. If you have an Ethereum developer, they have a very different sentiment about Bitcoin than Bitcoiners would, and vice versa. But it's also very collaborative. I mean, when you go to these events, you go to these conferences, there are a million different projects that are technically competitors, but they're speaking on panels together. We're all friendly, even if we're nasty on Twitter. Like in person, we're actually okay. I would say just use cases, as many use cases as you can.
So for us, we are not a layer 1 blockchain. Actually, for all the layer 1 blockchains, actually, truly our collaborators. We are not competing with them. And as I talked about it one more time, that I think our main strategy for attract people is to rebuild the production system. But more importantly, I agree with you that currently I think the cake is still too small. We are too early to talk about competition. I still think blockchain is still main competition in the traditional context. But if you are building a gaming platform, you are not competing with some other blockchain gaming. You are competing with those Blizzard, with Tencent, with these companies. You are doing IoT, you are competing with IBM these traditional companies. But I think currently we should all work together to push the blockchain technology in general to mass adoption. Then later worry about competition.
Are you sure?
Sorry. I personally have a company who build solution over blockchain technology. Over these years, we started with Ethereum. We also make some work on Rust over Scale, and then with Cardano. I continuously round the space looking for new options like yours. But from the point of view of the technology, it's impressive what you are doing. But then I see that there is like a lot of work to learn how to use your blockchain, for example. And my question is, who is your customer? Are the blockchain companies, blockchain development companies, your customers, or you are thinking about, I don't know, other people?
So I think for Celer, we are building both platform infrastructure, underlying basic infrastructure, and also some specific application verticals. So we build both the traditional like the business and the application developers, and the particular vertical like currently gaming daily users are all our customers. So we have users download our app, play games, and we are also talking with the enterprise collaborators to exploring how can we use layer 2 technologies to push decentralized applications to a massive scale. Yeah.
So by our customers, blockchain development companies, you mean as like a service provider building different blockchain apps on a blockchain?
Yeah.
Is that, yeah? Like for us, I wouldn't say that's explicitly our direct client, customer. We are looking more for again, more traditional financial applications or just legacy things that we can port over easily. The thing actually my job is to target people like you or developers that you may hire, because building on our platform, at least building on Algorand is very simple. There's a massive learning curve to understanding the consensus protocol. It will give you that. Bitcoin was the first big learning curve, and this is my second. But at least using it is simple. But our customers typically are like bigger organizations, generally.
So I think this is sort of how you build, like for us, right? For Taraxa, how do we build our product? What is our core offering? So for us, we like to always start with solving a problem, right? So we go to clients that have problems that we can solve. And then once we solve that problem, we take that solution and we take a step back and we say, is this solution generalizable? Can we generalize the solution into a set of templates or tools that then other people can use, right? So I think you might be the target, or these blockchain development companies might be the target for those generalized templates and tools. But we always start with the end customer who has the problem, because otherwise if we started making tools just in vacuum, right, it's pretty much guaranteed that we'll be making the wrong thing. So I think for us it's more like, sort of an iterative cycle, is that we have a hypothesis of what the tools might be, but we're using it internally, right? And then we solve some problems, then we come back and we say, how can we adapt these tools to be more problem specific, right? And then that becomes more useful, I think, for developers at large. It's always a little tricky, right? Because when you're talking to end clients, like I said before, they don't want to hear about blockchain, right? They don't care about blockchain. They don't care about decentralized. They don't care about any investment. They just want to know, is my problem solved? Am I making more money now? Right? That's what they care about. It's really a step-by-step focus.
Follow-up question to what you just said is really interesting. When you approach these clients, what kind of business, I would say, what kind of resistance do they have if they just want to make money? Because they're going to have to, what's their return on investment? Do they ask that? Because you have a hardware component, and how long does that last? Like, for example, the parking lot. Does that last for years until blockchain becomes more standardized? Well, not standardized, but more, like you say, 5 years. What happens between 1 and 5 years? They're going to put some investment in some hardware. And so how does all that work? What do they say? What are the rejections?
That's a lot of questions in one. Just use the arcade easy problem, right? So the first time we met them, it wasn't anything about blockchain. It was an introduction from another business partner. And these guys making arcade machines. You guys are hardware people, you want to talk to them? I said, yeah, sure. Talk to them about the business, we're growing very quickly, we're expanding overseas, but we're running into problems. What kind of problems are we running into? Well, we can't get reliable data. We can't trust our partners. Well, why is that? And we start talking, and then we understand that there's actually a major trust gap between this entire business. Then, of course, you got to calculate the numbers, right? How much money are you losing because of this, right? So they do a back-of-the-envelope estimate. They ask about some of their operations people. They estimate that they're losing at least $100 per month on every single machine, every month, at least. Okay. Well, that's very simple. These hardware modules are they're literally worthless, like $20, right? And they last for years and years, right? And the amount of data that we're uploading is minimal. It's like, how many times did this machine get played? What is that? That's like an integer, plus a timestamp, plus a signature, not a lot. We use a 2G network that costs 50 cent RMB for 2 megabytes per month. Also, basically negligible, right? So there's $100 a month problem we can solve for less than 1% of the cost, or 1/10 of a percent of the cost, right? So of course it makes sense. Right? So yeah, it makes sense to them because it helps them make more money at a minimum amount of cost, right? And our client has over 20,000 orders that they won't dare accept because they know they'll lose money on all of them if they don't have a solution like this. So we just make them money on opportunity costs, right? Future revenue generation, right? Not you also mentioned that they'll have a great day on the secondary market. They're not a crypto company, of course. They're a listed company in Japan. They'll have a great story to tell their investors as well, right? So this is all money. They make money every step of the way, right? So of course they like our solution, for next to nothing, right? So before you start deploying these solutions, you have to run through the numbers, right? Does the cost make sense? Does the investment make sense? Does the return make sense, right? And our returns are astronomical, right, compared to the cost of the putting in. So of course, this is something you have to make sure is discussed and understood at the very beginning, or else you're just basically going down the wrong route.
Since the time is already 8 o'clock, I think we can accept the last 2 questions. Okay, are you? Okay, if you don't have one, I actually have 2 questions. One is from one of the students who's watching the live streaming. So do you have questions now you can show me? Okay, I will ask the first. So what kind of challenges are you experiencing for both of the 3, from both a technical and commercial perspective when dealing with the real world problems?
I'll just be very quick, right? So, I mean, first of all, we run into a lot of problems because as soon as you start talking about things like blockchain, then people start freaking out about keys, right? They have this key that they can't lose. Right? If they lose it, it's disastrous. It's also a very good thing that currently none of our applications involve any kind of assets. So the worst thing that can happen when you lose a key is you lose your identity. You don't lose money. So at least that part of it is good. So that's a technical challenge right off the bat. Right? So we're currently trying to come up with ways of using layers of key generation. So the clients will have multiple keys. Every one of those can generate other keys that they use on a daily basis. So if they lose those, they can go back. If they lose all of them, then they're kind of screwed. There are also other technologies out there that uses, multi-party computations to generate keys, but that's likely to be super complex. That's something that they don't understand. So this idea of key management is actually pretty tough because what they really want is password recovery. Right? I lose my key, you got to recover it for me. If I recover it for you, that means I have access to your key. So that's always really been a challenge. There are technical solutions, there are business solutions. It's a matter of whether or not the client is able to understand it. A lot of this is very advanced cryptography stuff, like zero-knowledge proof and multi-party computation is very difficult. Very, very difficult for the client to understand. They don't understand what it is, and they don't understand it. They're not going to use it. They can't trust it. So we're really sort of at a point where it's good technology is not getting used because people can't understand it. Right? So it's a little interesting.
So our biggest challenge is it's education across the board, both on the business side. Again, I mean, it really goes back to what Stephen was saying, just explaining what Algorand is, what blockchain is, and then what Algorand is as a derivative of blockchain, and what Algorand is with respect to everyone else in the blockchain ecosystem. So it's education first and foremost. And then also for developers too. So again, I'm a developer, and part of building this critical mass of devs. We can go after crypto and blockchain developers, but they represent such a small percentage of developers worldwide. So what I've decided to do is to go after non-crypto, non-blockchain developers at standard conferences like JSConf, Python, and any of the PyCons. Because our SDKs are written in Java, JavaScript, Go, and Python. But the challenge there, again, is education. Because if they've heard of blockchain, all they've heard about is speculation. They think you really are full of shit just when they meet you to begin with. I don't blame them, but it's explaining to them what the utility of this whole thing is in the first place. So that probably will be an organic process to resolve education.
So I think for us, both the technology and the commercial business challenge are the same from the user. The user wants more. So you can talk about we have blockchain. It's trust-free. You don't need to trust us. It's secure. That's good. But then when they start using it, at that about why it's slower than my partner in non-blockchain app, they immediately go away. So what we are doing is we keep optimize our code. We have to do very deep algorithm engineering optimizations on every component of our system to make our product, make our system to keep all the good features of the blockchain, and also to be able to compete with the normal apps that most users are already used to have. Yeah.
So, does anyone here want to raise a very last question? Okay, sure. So there's a student majoring in Berkeley online, and he told me that he just wanted to know that how to get into blockchain and the regulation as a new student. Like, what kinds of advice
depends on which year are you in. So I would say if you are graduate senior, for now just spend 5% of your time to know about the blockchain and focus on traditional ECS stuff, on distributed systems, on cryptography, on networking. Knowing about this buzzword of blockchain, about trust-free, decentralized, it seems cool, but when you start to do real stuff, you immediately find out what we really need. What you really need is the foundation, the deep computer science foundation, how to build real large-scale distributed system, how to build secure system. The most positive, 99% of our work has nothing to do with the blockchain plus term. It's just to build a reliable, high performance and secure distributed systems. Yeah, so stick to the current course. Yeah.
Yes, so what I tell my students every term when I start my, so I teach at Miami College fundamentals of blockchain and crypto. So I kind of disagree a little bit, but I'll explain why. So what I tell my students is that this space seems to be the combination of computer science, economics, and game theory. Luckily, actually, Algorand, there's a bunch of PhDs on that's represented. So the computer science fundamentals are like obviously important. That's how everything is defined. But so are the economics, I think, and to a certain extent, maybe the game theory as well. So you're going to hear this buzzword of crypto economics, and there's so much debate as to whether or not that really is a thing or not. And I'm not even sure myself. But because it's so interdisciplinary, by the way, you do get pretty strange people that are in this space because it takes a very specific type of person to understand those three disciplines well enough to understand it and then be able to manipulate it. So what I would say is that if you have the option and the mental capacity to do a CS degree, do that. But I would say from an empirical standpoint, look at Bitcoin. Bitcoin is the only cryptocurrency that's actually delivered on what it was designed to do, which is an environment for censorship-resistant transactions. You can send money to WikiLeaks and no one's going to stop you. That's defined by a free market of energy consumption. No coin has been able to deliver on its exact promise. And then look at Ethereum and understand maybe why Ethereum has hit its limitations technically to a certain extent. Once you have those two dominant use cases down and understood, then you can probably look at the rest of the space pretty well.
Once again, definitely agree that with Xiaozhou that you should not fail your classes. That's really important because if you do that, you're not going to understand anything that's in blockchain. But yeah, once again, if you have bandwidth, I would say that go check out some of the open source projects. I mean, I would encourage everyone who's interested, go take Ethereum's code and take Bitcoin's code and just run your own network on it and just see what happens. And look at the network, observe the traffic, look at our database structure, see what's happening. Right? I mean, I think a lot of what we learn is through observing these original projects and see what's happening. The technologies are not novel. They're all existing technologies. It's just put together in a very, very interesting way. So it's blockchain is really a systems play. It's a systems play. So so go deploy some of these systems and just observe them. I think that you can learn a lot. You can learn a lot from them.
So much our three speakers for answering those questions. And thank you for coming today. And we hope that you enjoyed the San Francisco Blockchain Week. If you have any further questions, you can just talk face-to-face with our speakers. Thank you so much.